Hi guys, in this video we're going to look at some example past paper questions on equilibria. So the first one says hydrogen has many industrial uses. It can be made by this reaction. The pressure of the equilibrium mixture is increased. Explain what happens to the position of equilibrium. First thing we need to do is count the number of moles of gas on the reactant side and the product side. So we've got 2 moles of gas on the reactant side and 4 moles of gas on the product side. So if we increase the pressure, the equilibrium will shift to the side with the fewest gas moles. So let's state what happens. The position of equilibrium shifts to the left, or we could say the equilibrium shifts towards the reactants. That would also get the first mark out of 2. Then we explain it. So increasing pressure shifts the equilibrium to the side with the fewest gas moles. In order to relieve that increased pressure. The next question is asking about temperature. So it says the temperature of the equilibrium mixture is increased. Explain what happens to the position of the equilibrium. We've got a positive delta H value. That's telling us that the forward reaction is endothermic. So we're going to say that first. The forward reaction is endothermic, which is heat absorbing, temperature going down. That's the first mark. So if we increase the temperature, it will move in the endothermic direction towards the products. So increase in temperature shifts the position of equilibrium towards the products, or towards the right hand side. In the endothermic direction. Then the last question says the reaction is carried out in the presence of a catalyst and at a pressure of 30 atmospheres. So this isn't considered a high pressure, but it is 30 times atmospheric pressure. And it says suggest why the manufacturer uses a pressure of 30 atmospheres, so 30 times normal atmospheric pressure. Well, it's to get a fast reaction, so to get a reasonable rate of reaction. But notice that increase in pressure, so a pressure that's too high, will shift the position of equilibrium towards the reactants, and we want to make hydrogen as a product. So it's about that compromise, to get a reasonable rate of reaction without shifting the equilibrium too much to the left towards the reactants.